So this is a historic time, and we'd like to ask you some questions, beginning specifically first, thinking about the Lisa. What was your biggest technical challenge, and how did you address it?
Well, actually, the biggest technical challenge was getting sufficient performance in graphics in order to use a graphical user interface. The Lisa had a full bitmap display, so instead of just dropping a byte in a memory location and a character showing up via a character generator ROM, a lot of pixels had to be set and cleared. And we weren't sure if we would have enough performance to do that. We started with a 2900 bit slice processor, and fairly later in the game, Rich Page said, hey, Motorola's got good silicon on the 68000. And we switched to that, and I started rewriting the graphics primitives to use that. We weren't exactly sure we were going to get enough performance that the graphical user interface would be practical, but we did.
You did, certainly did. As you think back about the evolution, can you talk a little bit about some of those aha moments that really set the course for what turned out to be a success?
Well, there were quite a few of them. One of them, we were used to the Apple II. It had these little game paddle knobs. And what I learned is that you couldn't write software that used those knobs because not everybody had them. And so I ended up, one of the decisions we came to is we needed to have a pointing device, a mouse, in the box as part of the Lisa rather than an optional add-on. Otherwise, you'd have to write a graphics editor that might have to work just with cursor keys. And that was a bit of a hard sell. I think Tom Whitney was the one who said yes to that. Another big aha moment was realizing that we had to use a white background. You're always going to print on white paper. And we were used to computers that had a black background and white or green text, and you inverted the text when you went to printing. But if you wanted to take graphics seriously, that wasn't going to work because a photograph would become negative when you printed it. And the Lisa hardware team were concerned that it would require faster refresh RAM, the screen might smear when we scrolled, it would be more expensive. But if we wanted to do graphics right, this is when Steve Jobs was still leading the team, and he made the call there, yes, we have to go with the white background for the sake of graphics. Here's another one. We went through many iterations of how to do the user interface items. And at one point, we had little pull-down menus on each window. But the problem is, if the window was over on the side, you couldn't get all of the titles. And if it was near the bottom, you couldn't get all of the items. And at one point, I moved the menus to the top of the whole screen, where you always had the full width and the full height. The team wasn't too happy with that. I brought in prototypes of that, and well, then you'd have to, if you're working down here, you'd have to move way up here. So we countered that by making the mouse pin at the top, and by adding mouse scaling, where the millimeters on the table to millimeters on the screen was not a constant, but depended on how quickly you move. So a rapid flick would take you right up to the top. So it was actually easy to get to the top of the whole screen. So moving the menus to the top of the screen was kind of an aha moment. We had a lot of little aha moments, a lot of little steps. Here's one. We were using menus. We would use Apple spouses as test subjects, and we'd put them in one room, and we had a half-silvered mirror, and an experimenter would be in the other side, and there'd be a video camera on the hand, showing their hand and the keyboard, and another on the screen with their face reflected in, and a mic hanging there, and we'd ask them to mutter under their breath a stream of consciousness what they're thinking about. So we'd give these people a task, here, edit this document and save it. And person gets to the place where they're supposed to choose between do it and cancel. And they look a little miffed, and they hit cancel. We say, wait a minute, we saw that last week. Somebody else did that exact same thing. They looked a little kind of miffed. So we played back the videotape and cranked up the volume, and it said, what's this dolt? I'm no dolt. So we hit cancel. So because we knew that it said do it with uppercase I, we couldn't read it as dolt with a lowercase l. The next day, we changed it to OK and cancel, and that got us through the night. It actually would have been better to say save and delete, more action words. But a lot of our engineering choices were made by users making mistakes and us paying attention to how did they screw up. And we were trying to make something that was user-friendly, and sometimes internally we said loser-friendly. But, we were trying to treat our customer with respect. But a lot of these things that we discovered were a matter of trial and error, not just sort of inventing it right the first time. We bumbled into the Lisa user interface one mistake at a time.
So in this iterative process, can you say a little bit about the team dynamics? Because it took a great deal of, trust and testing, as well as clear decisions so that you could make your way forward. Can you talk a little bit about those team dynamics?
There wasn't always clear consensus.
Okay. Or however it was.
So what we had, we were developing using an Apple II that had a graphics card in it that displayed a bitmap that was 720 by 360 pixels. And that was our prototype environment. And we wrote in the UCSD Pascal system driving that graphics card. And I worked on graphical primitives that helped interface between there. But what I would do is I had one of these prototypes at my home. I did most of my coding at home. People were buzzing around too much at Apple. But I would take a Polaroid and bring it in and discuss it with the group. And ideas weren't initially accepted. It took a lot of, I think I would first bring them into Larry Tesler. He was kind of the most receptive to changes, and I thought he had good user interface sense. And I would show him something, he'd give me some encouragement, maybe some suggestions, and I'd go back and work some more. But often we'd get in a meeting room with 11 people or something, and we didn't come to consensus right away. Some of the things took a while to be adopted. Other things, an idea would come in and it would be against the grain, but it would be adopted overnight by showing it to each of the people. An example of that, Larry had a license plate, no modes. That was his California car license plate. And that reflected the fact that they learned early text editors sort of had cursor keys, and you could get in a delete mode. And now wherever you moved the cursor, it would delete that text. And that was kind of dangerous. So they had learned it was better to select first and then operate. So you select a range of text and then say delete it or make it bold or move it to another place, something like that. So that was the meaning of no modes. But Rod Perkins was working on a structured graphics editor, and you had to be able to draw lines and circles and rectangles and erase things and things like that. He was working under the constraint of no modes. So what it looked like is you'd have to drag out a rectangle of marching ants and go to a menu and say, put an oval in it. You didn't get to see the oval while you're dragging it out. And because we had this religion of no modes, we couldn't see past that this was a little backwards. Normally, when you draw something on a piece of paper, you pick up a crayon, and now every stroke you make is making marks with a crayon. Maybe you pick up an eraser. Now something else is happening. So I saw that the creation stroke required to be in a mode. And so I made a little string and baling wire mock-up of that worked but wasn't production quality code. And I brought it around. I set it in front of Rod Perkins and showed him dipping into a tool palette of tools. This was the first tool palette, and it was a way of having a mode, but at least having the mode in front of your face. Dip into a rectangle palette, and it lights up, and now you're drawing rectangles. Dip into a line, and now you're drawing lines. And so the tool palette. Well, that was an example of bringing an idea in, and I showed it to one person after another on the team, and Rod tried it and went, yes. And I showed it to the next person, yes, Mark Cutter, or each person. And so that one didn't really go through the committee review voting on it. I just brought it around, and each person saw, yeah, this works. This is much easier than what we were doing. So user interface issues weren't always clear-cut what the best way to do things were. We didn't always have agreement, but we iterated into a final solution that worked pretty well. We still made mistakes.
Fascinating, thank you. Well, since you're talking about Larry, we're certainly missing him at this time. Could you talk a little bit more about his role in the Lisa story, and in particular, if he were here, what might he say or what he talk about in his role?
Well, Larry was riding herd on the 7 Lisa apps. So Lisa came with a set of applications, a word processor, a spreadsheet, a project planner, a list manager. I think maybe some of the first clients of the Lisa were NASA, used it for project management. Anyway, there were 7 Lisa applications. Oh, application is a Larry Tesler name. I wanted to call them software programs. I thought an application is something you filled out when you wanted to apply for a job, or an application of paint. But no, he said they're software, they're applications. Okay. Well, what Larry did is went around to each of the 7 teams that are working on these different Lisa Office applications and tried to make them more consistent, so that if you learn how to do something in the word processor, you'd know how to do that same thing. Let's say you wanted to save or print or different operations that were the same logical operation but in different applications. So part of what Larry was trying to do is make the computer easy to use and make it have consistency between applications. Hopefully the 7 apps that Apple shipped with it would provide an example of user interface standardization that other application writers would follow. So for example, there's always a file menu and an edit menu. And when you have an edit menu, the items are always in the same order. There's always cut, paste, copy, undo. Larry was a big proponent of undo because it made the computer safe. People could try something knowing that if they messed up, they could hit undo and it'll go back the way it was. So Larry went around to each of the 7 app teams and said, well, what is different in your state before and after this operation? Is there a way you can encapsulate that in such a way that you can back out of that operation? Larry would say computers should be for everyone, not just for nerds. At the time before the Lisa, most computers were command line oriented. You type something at a computer and it typed usually complained, but it was sort of a textual interaction. But making the computer more graphical and based on pointing and graphics could make the computer useful to a lot more people that were never going to be computer nerds. So I think Larry would be happy with what we achieved, and what we have today in the general interaction with computers, whether it's on a Macintosh or on Windows or whether it's on our smartphones or tablets, it's based on a graphical user interface that was first made really available on personal computers with the Lisa, and then a year later on the Macintosh.
Let's talk more about that. If we were to zoom out and take a broad perspective over time, what would you say would be the most significant impact of Lisa, not just in computing or in the industry, but sort of on society?
Maybe the idea that computers were for everyone instead of just for a select group of nerds. That people who had musical inclination or artistic inclination or just anybody could use one of these. It's not just could, but would want to use one. It had to be fun, and it had to be relatively self-teaching, because people don't like to read manuals. So I think computers are now pretty much ubiquitous. A huge portion of people have smartphones in their pocket today. And, Lisa sowed some seeds that contributed toward that trend. I'm not saying that trend wouldn't have happened without the Lisa. Something else would have come along. Sometimes there are ideas in the air, and the right person puts up a catcher's mitt and catches the idea. And if they didn't, somebody else would have caught it. Things would have progressed in that direction. But the Lisa contributed toward the idea that computers were for everyone.
We have the advantage now of decades of perspective that we can look in retrospect at that. Since you were iterating forward, can you share when you might have had a sense that, oh, you and the team were onto something big, that there was something special here? Was there a moment or a time?
Right from the moment I joined Apple in April of '78. Steve Jobs recruited me. My friend Jeff Raskin, that I knew from undergraduate, he said, come down to Apple. There's something really cool starting up. You got to be part of this Apple computer thing. And I said, no way. I got to finish I was working on a PhD in neuroscience. And he sent me round trip airfare. And my dad lived nearby in Los Gatos. And so I figured, what the heck, I'll spend a weekend. He said, no strings attached, just come and visit. Well, Steve spent the entire day with me. And what he said then is what fired me up. And he said, what you read about in tech news really happened 2 years prior. There's a lag time between when time something's invented and time something's available to the public. If you want to change the world, and he used the phrase make a dent in the world, but he meant it in a good way. If you want to change the world for the better, you have to be ahead of that lag. And then he gave me a visual. He said, think how fun it is to surf on the front edge of a wave, and how not fun to dog paddle on the tail end of the same wave. Come to Apple, and you can change millions of people's lives. Literally 2 weeks later, I had quit my PhD program. I moved down to Silicon Valley from Seattle, and I was working at Apple Computer. And I knew right from the beginning that what we were doing was going to change the world in a good way. And Steve just sort of put that bug in my head. It was not about making money. It was about doing something useful and beautiful. Steve always talked about our work as art. He said, real artists sign their work. So when the Mac came out, or was about to come out, he had us all sign on a piece of paper with a Sharpie, and then he had that engraved on the inside of the hard tooling. So every Mac had our name on the inside of it. So, he wanted us to take pride in our work and treat it as an artistic expression, not just engineering. Engineering requires art also.
So as an artist, as you take pride and you reflect, what are you most proud about in terms of your role for Lisa?
What am I most is hard, because that means you have to narrow it down to one thing. I guess QuickDraw. I'm proud of the performance that I achieve with all my measuring and unrolled loops, and just making it so that you could do this without a graphics coprocessor, and I'm proud of that work. For the Lisa, I wrote the window manager, event manager, and menu manager in Pascal, and the QuickDraw graphics primitives, which at the time were named, I think, Lisa Draw, but then that name got used by an app, so we didn't want to have the name Lisa in it when it became used on Mac, so we named it QuickDraw. But QuickDraw was actually the biggest part of my work. Well, it was all 68,000 assembly language with a lot of optimization.
If you were to put the hat on for somebody who wasn't here for the beginning of Lisa and may not even, as a general public member, really understand the evolution of computing, what would be the most important thing for that kind of a public person to understand about Lisa and its significance?
Imagine having to interact with computers only by keyboard. No pictures, just words. Everything is by keyboard. Now, look how we do interact with computers. Everything is graphical.
That sums it up so well. Sometimes people have misunderstandings about Lisa or myths. Are there any that you'd like to dispel?
Well, one misunderstanding that people have is that after Jobs engineered a visit of the Lisa team to visit Xerox PARC, that we saw what they had and then wholesale copied it. And that's just not true at all. We were inspired to see their system. I think this was their Alto, their older system. And then we went home and we did a whole lot of engineering, and we didn't just copy what was there. We step by step made lots of blunders and lots of user testing, and iterated into a workable user interface. So it wasn't just, we copied Xerox. That's just not true.
That is a common misconception, so thank you for clarifying that. Anything else that you'd like to go on the record for helping people understand?
Without Lisa, there never would have been a Mac. Lisa was not a financial success for Apple, and the Mac almost bankrupted Apple because they cannibalized the Apple II. But in many ways, the Mac was folks' Lisa. It's how can we make the graphical user interface, point, click, and drag, how can we make that available at a lower price point that more people can afford? I think the Lisa came out at like $10,000. We were actually a little upset that they bumped the Mac up to $2,500 the last minute. We thought it was going to be $999. We were trying to make the Mac for a 15-year-old. We were trying to make the Lisa for an office worker. And because we weren't really office workers ourselves, we didn't really know. We were too afraid of offending people. The Mac, we were just having fun.
Well, those are the questions that I have for this segment. Just for fun, do you want to say happy birthday, Lisa, at the end?
Sure. Happy birthday, Lisa.